Okay, not today. So today we will try to write a recursive descent parser for this grammar. So what does a recursive descent parser mean? It means a parser that implements top-down parsing, and it works fine when the grammar is an LL1 grammar. If the grammar is an LL1 grammar, then we can do a recursive descent parsing. And the idea is very simple and it's very intuitive. So the idea is to write a procedure or a function for every non-terminal in the grammar, and you just try to go through the derivation recursively, because in a top-down manner. But there may be some recursion involved because the grammar is recursive. So all interesting grammars are recursive. If a grammar doesn't have recursion in it, then it's not interesting. Okay. In fact, it will only if it doesn't have recursion, then it will generate only a finite number of strings, and if a language has a finite number of strings, then what can you say about that? What can you say about the category of that language?
It's a regular.
It's regular. Yeah. If it has a finite number of strings, it's regular, because you can write a regular expression, which is just the ORing of this finite number of strings. So if there is a million strings in the language, you can OR them, and that's a regular expression, and that's a regular language. But if you have an infinite number of strings, you cannot OR them. Okay. So the idea is we start from the top. So we have a main function for the recursive descent parser, and this main is going to look at expression. So the start variable is the expression. So it's going to call the function that will recognize an expression. So it will call result equals, well, before it calls expression, it needs to get the next word from the scanner. So the first step is word equals get next word from, so this is getting the next word from the scanner. Okay. Then it's going to call expression, which is the function that parses an expression. And if the result is true, and if we don't have any more words left in the input string, then we are fine. So if we parse an expression and there is at least one word remaining, then we are not, this is not correct parsing. So after we parse an expression, the word should be, and let's do this, or let's write and. Word equals end of file, then everything is correct. Then report success, else report fail. This is at the top level. So it's basically all the work is done in parsing an expression. And parsing an expression, again, we need another function for parsing an expression. And this function for parsing an expression is term expression prime. So it's going to call the function that will parse a term. Then it will call the function that will parse an expression prime. But if the function that parses the term returns failure, then there is no point in parsing an expression prime. So we know that the parsing process has failed. So first we call term. If it returns successfully, then we parse an expression prime. If it doesn't return successfully, then parsing has failed. So everything has to pass in order to pass the entire input string. So remember, when we call term, term inside of it may have lots of recursive function calls. So we call term, so result equals term, and if result equals false, we just return false. We have just failed. Now, if the result of term is success, then we call the next, which is expression prime, and we return expression prime. Return expression prime. We call expression prime, and we return whatever expression prime returns. So this is expression. This doesn't have much because it only calls two functions. Now, expression prime has more work to do. Expression prime, what expression prime does now, expression prime will succeed if the character that we are seeing in the input is what? Plus or minus or no. It's plus or minus or. So when will this be possible?
Or empty.
No. When will the epsilon substitution be possible, be correct? If what we are seeing in the input belongs to follow set of expression prime. So if what we are seeing in the input is a plus or a minus or something that follows, that belongs to the follow set of expression prime, then we can make a correct substitution. Otherwise, there is something wrong and we declare failure. So the follow set of expression prime means we are substituting epsilon, so we are deferring the substitution until a subsequent step, but this will make sense only if what we are seeing in the input belongs to the follow set of expression prime. So if word equals plus or word equals minus, if it's plus or minus, then we call term. So there is something that we have to do before we call term. If the word is plus or minus, there is something important that we have to do before we call term.
The next word?
Yes, exactly. To get the next word to consume this and to advance the pointer in the input. Because we are now recognizing this, and we should advance the pointer beyond the plus. Okay? So now we should advance the pointer. So word equals get next word, and we call term. Result equals term. Now what happens next?
Check the result of term.
Yeah, if the result of term is false, if result equals false, then the whole process fails, so return false. If term is parsed successfully, we successfully parse a term, what should we do? Call the next symbol, which is expression prime. So if this is successful, then we call expression prime. So return expression prime. So this is if it's plus or minus. So we will return true or false. Now we can put an else or just ignore an else, assuming that we are using indentation here to indicate that this block of code is belongs to the if statement. So it's only so this is pseudocode, and indentation here is significant. Okay. So now if this is not true, then we will check if the word equals what?
Oh, the follow set
The
of.
follow set of expression prime. And the follow set of expression prime is end of file or close parentheses. End of file, or let's be consistent, or word equals close parentheses. Then in this case, what will happen? What should we do? What do you think we should do? So there is nothing to call, right?
Yeah.
Return true.
Back.
Just return true. Yeah, exactly. So if this is just return true, then what should be the final thing to do?
Return false.
Return false, exactly. If none of these, if we're not matching with any of these, then we return false. Now, okay, I forgot something here. Before we return, what should we do?
Oh.
Because we are recognizing no, sorry, we're not recognizing. Sorry, it's an epsilon, so we're not recognizing. Sorry. When it's an epsilon, we are not recognizing them. We are going to recognize them later, so we just return true, and then we return false. Remember, when it's an epsilon substitution, then we are not consuming a character from the input, so we don't call get next word. Okay. Now, this is for expression prime. What's next? Term. Term is easy. It's similar to expression. So term is going to say, okay, I'm going to call factor. It's going to say, I'm going to call factor. And if result equals false, return false. If result is true, else return what?
Term prime.
Yeah. Return term prime. Okay. Okay, so this is term. So we parse the factor. If the factor is successful, we call term prime, and we return whatever term prime returns, which could be true or false. Then we call term prime. Now, the function for term prime is going to look similar to what?
Expression prime.
Exactly. Term prime. So in fact, we just term prime. Oh, let's do it very quick. So if word equals what? It's not going to be plus or minus. It's going to be times or divide times or word equals divide. Then we do the same thing. Word equals next word. Word equals get next word. Result equals what? Result equals factor, right? Here we are calling factor. And then if result equals false, return false. Else, if it's not false, return what? Return term prime recursively. Term prime. And if word equals what? Follow set of term prime, exactly. The follow set of term prime, which is end of file, close or plus or minus equals Okay, end of file, or I'm not close parentheses, or forget about the syntax here. I'm not gonna. I should write word equals, but I'm not gonna do it. So plus or minus. Okay, you should write word equals this, word equals this, word equals this. Okay. Okay. Then if it's any one of these, then we do return true. Or let's say return true.
So it's the follow set of term prime.
Yes, exactly. The follow set of term prime. Return true, else return false. Return false. Okay. Now, okay, yeah, I don't know if this is going to fit. So now we will do the factor. Factor is interesting. It's a, yeah.
For if result is equal to false, return false. Then the next one you say return term prime is then how do you want to do it?
Yeah, so it means that if this is, we can put an else here, but the else is not necessary because it's going to return. Right, so if it's false, then return this, else return term prime. So there is a redundant else here that is missing. You can put a redundant else if that's more comfortable, if you find this more readable. But it's redundant because you're going to return. If it's false, it's going to return. You will not get here unless this is false.
Unless it's true.
Unless it's true, sorry. If it's false, you'll return. If it's true, you will get here. So the else is redundant. Okay, so factor. Factor is similar to term prime to some extent, but let's do the expression prime because it's the tricky one. Now it's okay. So first, let's recognize the expression prime. So if word equals open parens, then we should recognize a what?
Expression.
An expression. But before we call expression, what should we do?
Advance the pointer.
Next word.
Consume it, exactly, by calling get next word. Consume it by calling get next word. Then we call expression. Result equals expression. And if the result of expression is false, we return false. Equals false, return false. Now, if result of expression is true, what should we do? If result of expression is true,
You have to check if
Get
the
next word.
yes.
Yeah.
And
Well, no, we got the next word, so we are a word ahead. So it's now after parsing an expression, the pointer will be here. So
Oh, okay.
this will be our next. So we haven't consumed it yet. So it's
Check
going to be the next. It's going to be the value of word.
Yeah.
Yeah.
To check it.
Yeah. So check if word equals what we are expecting equals close parentheses, then this is correct, and we should what?
Return true.
Yeah, exactly. Return true, but before we return true, we should consume it. So remember to consume it. So if word gets this, then get. I think we can do it here. Okay. Get or word equals get next word and return true. because we have just recognized the factor that consists of an expression between parentheses. Okay, he returned false. Okay, so now we are here. So if the word is not close parentheses,
Return.
then we return false. Else return false. Okay, so if expression is returning false, we are returning false. Otherwise, we continue and we check on word. If word is this, the expected word, then we consume it and we return true. Else, we return false. Okay, now all of this checks for this option. Now, the other options, I'm going to put the rest of factor here. So this is factor continued. Okay. So the continuation of factor is going to be checking for ID or number. So if word equals ID or word equals number, if it's an identifier or a number, what should I do?
Consume it.
Consume it first. So word equals, so I consume it, get next word, then return true. Then what should be the last line?
Return false.
Return false. Okay. So this is this is the recursive descent parser for the classic expression grammar. Now, let's see if we can, trace this on a. Let's see if we can trace it on a string like the string that we did last time, which is x plus 5 times y. This is an expression. So how do we trace this? So first we are in main. So get next word is going to get us the x. This is our next word now, the x. Get next word gets us the x. So this is what we are seeing in the input. And on the stack, we have, this is our stack. Our stack will have the main. Then main will call expression. So expression, function expression is going to be on the stack, on the called stack. Now we go into expression. What does expression do? Expression calls term. So we are pushing this on the stack. Now we go into term. Term calls factor. So term calls factor. Okay. Now we are inside factor. And factor is going to match what we are seeing. What is this? This is an identifier, right? So factor, this is not going to match. So it's not going to execute this. But this will match because it's an identifier. So it will call get next word to do what? To consume the x. So we will advance the pointer. And we will consume the x. And then it will return true. So it will return true. Now factor will return to what? It will pop factor.
Term.
And it will return to term. So this is the stack. It will return to term. Now we are here in term. And if the result is false, return false. It's not false. it's true, so it's going to return term prime. It's going to call term prime now. It's going to call term prime, and in term prime, it's going to look, is it a multiply or a divide? No, it's not a multiply or a divide. But if the word is, so here we are looking ahead, but we are not making any substitution. So if the word follows, if the word that we are seeing is a plus or a minus or an end close parentheses, then we are doing an epsilon substitution. We are not consuming it yet, but we are making an epsilon substitution, so we are just returning. So term prime returns without consuming anything. This is equivalent to doing an epsilon substitution. So term prime returns. It returns to the function that calls it, which is term. Now term is going to return true. So term is going to return to the function that called it, which is expression. And expression is going to return expression prime. So it will call now expression prime. Expression is going to call expression prime. And expression prime is going to match this plus here. So it will execute this. It will get next word, so it will consume it. Now we are pointing to the 5, and it will call term. Okay. Now it will call term. Term is going to call factor. And factor is going to recognize this as a number, right? So it will recognize it as a number, and it will get next word to consume it. So we're here now. And factor is going to return. So it will get popped off the stack. Factor will return to the caller. The caller is term. We are here. It's true, so we'll call term prime. Term prime. Now term prime is going to match this. This is what? This is multiply, right? So it will recognize the multiply, get next word to consume it, and we will advance the pointer, and it will call factor. So term prime will call factor. Again, factor will recognize what?
Identifier.
An identifier. So factor will recognize this, and it will get the next word to consume it. So our pointer is now pointing to end of file. Okay, and factor is going to return to term prime. Now term prime is going to do what? It will match the next with end of file, but it doesn't consume anything, so it's an epsilon substitution, so it's going to return. Then we return to term, and in term, that was term prime, so it's going to return. So term is just going to return. And term is going to return to expression prime. In expression prime, we are in term, so, right? So expression prime called term. So it's going to return expression prime again. And sorry, not again. So it's going to call expression prime. Expression prime is going to call expression prime. Was this the expression? So
Yeah, that's all right.
yeah, yeah. So the term is going to call expression prime, right? So this is we were in term. So expression prime
Yeah, and
is
it's going to return true again.
expression prime is going to match this with end of file, and it's an epsilon substitution, so it's going to return without doing anything. So now, yeah, so now expression prime is going to return true again. So it's going to return to expression. And expression, just called the expression prime, so it will return true to the main. And the main now, after calling expression, it will find the word as end of file, which is what it is expecting. An expression has been parsed, and we are pointing at end of file. So this is a successful parse. Okay. So should we do an unsuccessful? So let's do an unsuccessful parse and see what happens. So let's do a string that does not belong to the language, an invalid program like x times plus, so plus times y. Okay, now let's see what happens if we do this. So main is on the stack. Main is going to call it will get the next word, so it will point at this. Then it will call expression. It will call expression. So expression is going to call term. And term is going to call factor. And factor is going to recognize the x, the identifier, and it's going to advance the pointer. Then factor will get popped off the stack. Right? Now we return to term. And term is going to call what?
Expression prime.
Term prime.
Or
Term prime.
Yeah, term prime.
It's going to call term prime. And term prime is going to, it's not going to match with this, but the next is going to match with this. So it's going to substitute an epsilon. It's not going to consume anything, and it will return to term without consuming anything. Then term will return, so it will return to expression. Expression will, after term, it's going to call expression prime now. Expression prime. Expression prime is going to match the plus, so it will consume it, and it will call term. So it will consume it. Expression prime will consume the plus, and it will call term. Now term is going to call factor.
Then it doesn't.
Now factor will try to match the multiply.
And it returns
So
false.
it's not this, and it's not an identifier, it's not a number. So because we are expecting a factor, right? And the multiplication sign or the multiplication operator is not a factor. So we are expecting a factor, but we are not seeing a factor. So now we are detecting an error. So factor will return false, and the false will propagate up all the way to the main. So this will return false, false, false. Each one will return false. Now the right place to print an error message, will it be up top or when the unexpected symbol is not found? Where do you think would be the right place to print an error message to the user?
In fact,
In factor, yeah. So we can tell the factor that we are, unexpected symbol times. So this symbol is unexpected. You have a syntax error at this point. This symbol, so you'll get an error message saying unexpected symbol multiplication sign. Okay? So this is how you get syntax errors when you compile.
Yeah.
So it's not the expected symbol. So now we print, in fact, it makes sense here to just print the error message here. Before returning false, print error message, meaningful error message. Like unexpected symbol. And we can see, the symbol is the word. So it's the lexeme that we are seeing. It's, the word that we are trying to match. So we can print what word is, the value of the lexeme. When we do the actual parser, you'll always have access to the actual lexeme. So you can say this is unexpected.
yeah. I think GCC prints a weird error message if you do something like that. Something about no transition between sequence points or something.
I don't recognize this error.
Yeah, it's a weird one.
Okay. Well, I've seen the. I mean, in this case, the error message that I see is unexpected symbol.
Yeah.
And it may tell you what it is expecting. You can tell it what you are expecting. What are the valid symbols? Anyway, so this is how it works, and it's recursive. So in order to understand this, you have to understand recursion, because it's recursive. The functions are recursive because the grammar has recursion in it. And like I said, any interesting grammar will have recursion in it. Okay. Any questions on this? Okay, so I will do something in the remaining 10 minutes. So far we have been writing a grammar. We have been only doing grammars for the expression. So many of you must have been wondering, how can we write a grammar for a program? So let's now try to write a bigger grammar, for a program. Well, not a whole thing. We're not going to write we're not going to write a grammar that describes a whole full-featured language in this space, but we will do something that is more general than an expression. So let's assume that we have a program our program, suppose that we only have a main for now. Well, if you know how to do the main, then you will know how to do all functions, because all what it is a list of functions. So let's assume that we have a main. So in this case, our program is going to be main open braces, and inside of this we will have a statement list of statements and close parentheses. So this describes a program that consists of a main and an arbitrary list of statements. Now this statement list, how do we express a list that consists of an arbitrary list of a list of statements of an arbitrary length? How do we express this?
We can have expressions or functions inside there.
But how do we say that the number of statements inside the main can be arbitrary?
Recursion.
Yeah.
Yeah, we could just call it self-recursion or epsilon.
Yeah, so we do recursion. So we do just statement list is going to be, you can do left recursion or right recursion. So it's going to be statement list or epsilon. Of course, by saying epsilon, we are allowing a program to have an empty body. So we are allowing a program that doesn't have any statements in it. Or if you don't like this, if the specifications are to expect at least one statement, then you replace this epsilon with statement. Right? Then the statement, let's do three kinds of statements. Assignment, or conditional, or loop. So these are three basic kinds of statements. And then we have to define each one of them. An assignment is what?
Starts with an identifier, then an equal, then an expression.
Exactly. So it's an identifier equals expression. Semicolon. And expression is what we have defined. We have defined it a million times. Okay. Then the conditional is, let's say it's something like if condition, then you can have an arbitrary number of statements, then else an arbitrary number of statements. So we can define a conditional as cond is if, and with open parentheses, and let's call this a Boolean expression. Boolean expression, and what do we have here?
Statement list.
Statement list, yeah. Statement list. Else statement list. So inside of this, if a Boolean expression, do a statement list, else do another statement list. So if you want the else to be optional, which is the case in the programming languages that we are familiar with, that should be easy. How can we make the else optional?
Just add another if.
Yeah, write another production that only has the if in it. And so you can do if, or if B expression statement list. Then you are allowing the else to be optional. Okay, so let's assume that the else is required here.
Well, what about, what about in the case where you don't put the braces and you just have one statement with a semicolon?
Okay, so in this case, you can say, okay, or if Boolean expression, what?
Single statement.
Statement.
Yeah, okay.
Okay.
All right.
So, or, so you always have multiple options. So this allows a single statement without braces. Okay, so you can do this. You can do any of this. And now the Boolean expression, in fact, this is in the assignment. So let's say let's define a limited form of Boolean expression, assuming that the Boolean expression is expression greater than, less than, or equal, not equal, another expression. So we can define a Boolean expression. This is not the most general definition. So in the assignment, it asks you to do a definition. And in the sample midterm exam that I have posted, it will ask you to generalize this definition of a Boolean expression. But let's do this. Expression, let's do a compare operator expression, where the compare operator or comparison operator is any one of these, greater than or less than or equals or etc. You list all the comparison operators that are allowed. Okay, so now this should give you an idea about how we define a grammar for an actual programming language. Then you can define loops. So I don't want to define everything because then I will be doing the assignment for you. Okay, but I'm giving you some ideas, some definitions. So now it should be clear, how we go about defining the different constructs for a programming language. And we will limit ourselves in this course. We will limit ourselves to the basic ones. So we're not going to do, for example, pointers or classes and objects and inheritance and any of these advanced features. We'll stick to the basic features. But in fact, if you learn how to do the basic features, it will not be very hard to do the more advanced language features. Okay. So any questions on this?